Hello YouTube, in this video we're going to use the definition of the derivative to find the slope of the graph of x squared minus 2 at a couple of different points, the point -3, 7 and the point 1, -1, which I can assure you are both on the graph, okay? So this is really just practice on using the definition of the derivative to first find the derivative function and then use that derivative function to find the slope of the graph at any point x that you plug into it. Let's go ahead and start with the definition of the derivative. Recall that the definition of the derivative, given some f of x here, we have our f of x, we say its derivative is denoted with f prime of x. Okay, so this is the derivative function. Recall that the derivative function, it has one job, it is the slope function. Okay, so it tells you the slope of your graph at any x value. So we say f prime of x is equal to the limit as h approaches 0 of this expression. So we have f of x plus h minus f of x all over h. Okay, so let's keep this in mind. We already know our function from above here. This is x squared minus 2. Rewrite it a little bit prettier. But we say we already know f of x for this spot right here. We already know h in the denominator, so we don't really need to kind of explore those. We need to explore what f of x plus h is. And so I kind of like to do this off on the side. We say f of x plus h. Let's go ahead and find this off over here on the right. F of x plus h is equal to, now we had x squared minus 2, so every instance of x we're going to plug in this expression x plus h. So we have x plus h. So in this case, we're going to have to binomial expand this. Binomial expansion here, we say x squared plus x plus, we get x squared plus xh, two of those, okay, so 2xh, plus h times h, which is h squared, and then all of that there minus 2. So we get this entire expression basically for f of x plus h. Now this is what we're actually going to have to plug in right over here if we want to find the slope of this graph at any given point, or find the derivative. So we're going to go ahead and find the derivative of this. We say f prime of x. Let's go ahead and begin this. We say limit. The limit as h approaches 0 of, now on top we had f of x plus h minus f of x all over h. Okay, we're just going to drop h in there, but we say f of x, recall f of x was just x squared minus 2, and f of x plus h, which was this expression over here, we said we're going to drop it in. Let's go ahead and drop this in. We get x squared plus 2x h plus h squared minus 2. Okay, so I tried to squeeze that all in there. On the right here, on the numerator, in the numerator, we say we can distribute our negative, which would make this now positive, but make this a negative and make this a positive. Okay, so positive, negative, positive. So our notice this, our negative x squared on the right here should cancel out with the x squared on the left, and we say this positive 2 cancels out with our negative 2, and hey, what do you know? If we rewrite this, we have the limit as h goes to 0 of, now it's all over h, but I said what do you know, because you notice everything on the left, everything left on top up here and on the left has an h left in it, and that's kind of nice because we say now we have 2xh plus h squared, and what we can do now is just use the dividing out technique for evaluating this limit. And I say that because if we tried to direct substitute the 0 in right here, we get zeros on bottom and on top, and that's indeterminate form. We say 0 over 0 is no good, no bueno. So we're going to factor an h out of the top, and now we get this new expression, the limit as h goes to 0 of this. So we have h is factored out. What is left is 2x plus h all over h, and now our h's cancel, and we're finally left with this expression that we can evaluate because we've removed the discontinuity. So we say 2x plus h is our function here. So if we were to direct substitute now, every instance of h would drop out because it approaches 0. We get this, we get 2x. So I just want to be really clear on this. This right here is the derivative function, okay? Derivative function. This is awesome. What does the derivative function do for us here, okay? So we say f prime of x equals 2x. Well, I'll tell you what this derivative function does for us. It finds the slope of our graph at any given input value or any given x value, okay? So let's say, for instance, I have a point that I want to find the slope of my graph at. As a matter of fact, I have two of them. Recall that I had negative 3, 7 from up here, and also 1, negative 1. Now I want to point something out. We're really after the x values here. This is what the derivative function runs on. It says you give me an x value, I'll tell you the slope. So what we're going to do is we're going to start by plugging in negative 3 into our derivative function. So we say f prime of negative 3 would be 2 times negative 3, which would be negative 6. And then we say, okay, now let's plug in our second x value, which was 1. We say f prime of 1, which was 2 times x, and this time x is 1, so we get 2. So what this means is these are slopes. But this one is at x equals 1, and this one here is at x equals negative 3. So let's go explore our graph here. We've got this graphed in GeoGebra. I can go show it to you here. So taking a look at this graph, I've already dropped in a tangent line. You notice we have this parabola here that's been translated down to units. It is x squared minus 2. But let's grab on this point here and just recall that the slope of a graph is equal to the slope of the tangent line of the graph at that point. So we said when x is negative 3. So what we're going to do is going to pull this point over here to the x value negative 3. And we're going to take a look at this. Now notice it snapped into place kind of up here. Here's negative 3. But we say, what's the slope of this line right now? Well, the slope of this line, you know, you'd say you go down like 1, 2, 3, 4, 5, 6, and then over 1. So like negative 6 over 1. But hey, what do you know? On the other page, we said, hey, you know, what's the slope of the graph at negative 3? When we plug that into our derivative function, look what you got. It said, hey, your slope is negative 6 there. And now up here, we're going to go back over to our graph in GeoGebra, but we're going to go over to the x value 1 and say, what's the slope? And we should get a slope of 2. So let's go take a look. So we're going to pull this point over here. Definitely it's got to be positive because it's going uphill, but we say an x value of 1. Let's find the slope of this orange line. Notice it goes up 2 over 1. So hey, way cool. We found the derivative function using this definition on the left. Found the derivative function first. And then said, let's plug in some x values in that derivative function to answer the question, hey, what's the slope of my graph at a given point? Okay, so cheers.